In this lesson, we're going to see how to turn an entity relationship diagram into actual relational tables using MySQL. So I provided the following ERD on Blackboard, and it's for a company called Gold Star. So Gold Star has employees that it wants to keep track of, different locations that the employees work at, and different positions that the employees can hold. So this is fairly simple, but it's a good place to start. So if we take a look, we can see that for a particular employee, they can only hold one position, and they will hold one position. And for a particular employee, they work at one and only one location. And but obviously a location can have multiple employees, and a position, such as manager, can be held by several employees. So that makes position ID and location ID both foreign keys in the employee table. So what we'll do is both see conceptually how this diagram gets turned into tables, and also a little bit about how to work with the MySQL database management system. So if you've watched the video on how to install MySQL, hopefully you have the Workbench component. That's what we're going to be using right now in order to create a database and manage it. So I'm going to use my Windows search bar to look for MySQL Workbench. And when you get into MySQL Workbench, you have made a user account, but what we're going to do is since there really aren't any security risks, I mean, you've just installed it on your own machine, we're just going to connect as the root so that we have all of the permissions that we need. So from here, you should be able to double click on the local instance, and it should open up the following window. Now, if this doesn't happen, I recommend searching for the error that you get, or just let me know what error you get, and I can try to post some troubleshooting techniques. If you're on a Mac, it might be a little bit more tricky for me, but I do have a Mac laptop that I'll install this on, and so hopefully be able to help you troubleshoot as well. From here, we are connected to the MySQL server that's on your machine. So this is not a specific database. This is a server that can host many different databases, and each database will have a corresponding schema. The server will provide a way for you to interact with different schemas that you define. So there's a default schema in here that is called sys, and there are actually quite a few different ways to create your own schema. And so what I'm going to do is show you a few different ways of creating the schema, and then you can figure out what works best for you. So in this section, we're going to be eventually focused on the different types of queries that you can conduct using what's called structured query language. And in order to get there, we also will have some experience with the data definition language, because we first have to create the schema, we have to create the database, we have to create the tables, basically create the physical manifestation of everything that we've put into the entity relationship diagram. Ideally, what we want to do is get to the point where you can actually write the code that will create the schema, the database, and the database tables, and then query those tables. But in order to get there, I think it might be helpful to see the kind of point and click method of creating everything, because once it is created, you can actually have it generate the script for you. So what we're going to do is go to File and New Model. And what we're going to do is use this as a development canvas for the schema that we want to actually instantiate. So by defining the model, we're not actually creating anything just yet. What this will do is allow us to see the underlying model, and then we'll be able to actually generate the code that we need in order to create the schema, the database, and the database tables that we're going to instantiate. So we have an entity relationship diagram that we want to work with. What we're going to do is double-click Add Diagram, and we'll work on this canvas that's very similar to Lucidchart for actually creating the model. Now here I've pulled up what's called the Gold Star Entity Relationship Diagram. This is an ERD for a company called Gold Star. You can see that they want to keep track of employees, locations, and positions. And each one of these entities has a primary key that's underlined. They have multiple attributes, and we can see the foreign keys in the employee entity. If we inspect the cardinality, we can see that an employee must work at a single location and also hold a single position. And then a position can be held by multiple employees. For example, if we have a position called manager, multiple employees can hold that position. And for each location, we have multiple employees that work in that location. So for example, we have the location Atlanta. We have multiple employees that are assigned to work in that location. The other thing we're going to do is introduce informally a few of the concepts that we'll talk about more in depth later when we get to normalization. And one of those concepts is called referential integrity. So referential integrity deals with the foreign key in the relationship. If I have an employee that has a particular location ID as a foreign key, referential integrity states that that location ID must be one of the available location IDs in the location table. And what we'll see is that MySQL as a database management system will help us enforce this referential integrity. The other integrity constraint that we'll informally introduce here is what's called entity integrity, in which if we have a primary key, that primary key must have a value. So again, referential integrity involving the fact that if an employee has a particular position or location, those positions and locations, the IDs that are identifying them, they have to be in the corresponding tables. And the entity integrity, meaning that if we have a primary key, it has to have a value. If we think more about what referential integrity really means, we can figure out that there should be some kind of order in which we create the tables in the model. Because when we put the tables in the model in MySQL Workbench, we're also going to be defining the physical schema that indicates the different data types and constraints for the attributes and the entities. So we actually have to keep these integrity constraints in mind as we're doing this. The implication here is that before we can create the employee table, we have to create the location and the position table. If an employee has a position and location ID, those have to be already available in the corresponding reference tables in the location and the position table. And it hasn't been said just yet, but the way that we've defined the entity relationship diagram will help us actually determine which tables we're going to have. So we're doing the logical and the physical schema almost simultaneously in MySQL Workbench. We're going to draw the diagram and then tell it how we want everything to be stored in particular. And each entity in the diagram represents what's going to become a table in the actual database when it is defined. So here we have 3 entities. That means we're going to have 3 tables. We have to create the position and location tables before we can work on the employee table. So let's start with the location table. On the canvas, you can press T, or I'm going to click on the Place a New Table icon and then click the canvas in order to create a table. To define what's in the table, I'm going to double click. You'll see that it brings up the following below. Now you'll notice it says MyDB for the schema. That's the first thing I'll point out. So we should probably give the schema that we're creating a better name. Again, we haven't actually instantiated the schema yet. We're just creating a model for it. So let's go over to the MySQL Model tab, and I'm going to right-click on MyDB, where the physical schema is. Go to Edit Schema, and then give it a different name. So I'm going to call it Gold Star, and then click Rename References, and OK. I'm going to hit Control S to save it as well. You can see that I've already kind of been working on it, but I'm going to call it gold star. And in my case, I'm going to replace it, but you can just save it as a new. And from here, you can see you have access to the tables that we're defining as well as the diagram that we're defining. So I'm going to go back over to the diagram. I closed the table window and then reopened it. And when I did that, you could see that the schema name has changed to gold star. So from here, what I'm going to do is first give the table a name. I'm going to call it location. And this is where the fun starts. So we're going to talk about all of these different types of constraints that we can add to the different columns in our table. But first, I'm going to double click the column name area and add our primary key. So I'm going to add location ID. And the PK, if I click that, that's going to indicate a primary key. The other thing that it's done is it's checked this NN box, which stands for not null. So that's what I was talking about. The entity integrity implies that if we have a primary key, that it cannot be null. Null meaning empty, so not null would mean that it is. So every time we have a primary key, we're going to check both the PK and the NN box if we use this dialog instead of the script to do so. I'm going to double click and continue to add attributes. So the next one being city. Now, from here, we need to talk about data types. So what I've done is provided a reference sheet for you by compiling information from both the MySQL documentation and some other tech websites. So if we take a look at that, what you'll see is a description of all the different possible data types in MySQL. Data types are something that are often different between database management systems. So what you find to work one way in MySQL might work differently in the Oracle database, it might work differently in Access. And so when you're working in a different database, you need to kind of pay attention to the documentation and make sure that it's not causing you any problems. So what is a data type? Data type specifies the type of data that it's going to be. So for example, if we have something we want to be numeric, we can choose from one of the following data types. So if we're dealing with an age or an ID, something like that, we might want to use a numeric data type. Now, numeric data types come in a couple of different flavors. The first being the integer types. So integer implying that there are no fractional parts. So in other words, you're going to have things like -1, 0, 4, 127, or even larger positive and negative numbers, as long as they don't have a decimal fractional part. So we might want to use an integer type for a primary key if it's an ID, or if you have something like age, anything that doesn't have a fractional part. There are various types of integers that give you different ranges of values, and you can see them here. So you have anywhere from very few options, from like -128 to 127, or very large options like I'm not going to read that number, but you can see under big int. And the other thing to notice here is that you have the signed range as well as the unsigned range. So if you're using signed values, that means that you have values that are negative and positive. And that's how the space is being allocated. When you have unsigned values, those are from 0 to a positive number. And here's an easy way to see what that means. If you look at the tinyInt data type, you can see that the signed values range from -128 to +127. The unsigned values range from 0 to 255. So the space is being allocated for more positive numbers in the unsigned range. And so being unsigned is one of the constraints that you can apply. Most often when we're working with integers, we will use just integer. Sometimes we'll use unsigned integers, but integer is going to be our standard. The other type of numeric data type are those that have fractional parts, or that are referred to as sometimes floats or doubles. And we have different ways of writing them. So float and double being the most common. With float, you can see that you have float and then an M comma D. So M is going to be the total number of digits that you have, and D will be the number of digits after the decimal. So this would be a great way to make a currency field in your database. If you want to learn more about the different specific data types, you can take a look at this website here, or look inside the MySQL documentation. There are a few other different general data types. One of the important ones being string data type. So a string, we're just talking about alphanumeric characters. You may have heard about this if you've done a little programming. You have different string variables. In MySQL, we have different options for strings. We have the char and the varchar, as well as different kinds of text. If we look at the explanation, we can see the differences among them. In particular, if we look at the difference between char and varchar, with char, we specify the number of characters that will be our maximum, but these are what are called fixed length strings. So if we don't fill up the whole string with characters, it will pad to the right to have the size be equal to the specified maximum size. If we use the varchar, then we have a maximum of the number of characters that we put in there, and it will be a variable length string. In general, we won't need to store things that are too long. If we need to store longer strings, we can use the text, medium text, or long text data types. We also have different ways of representing dates and times. So ranging from just date, date time, we have a timestamp that shows the current time value, time, and year. Now, you have to look very carefully at these. From personal experience, date and time data types are very picky. Well, I should say the database management system that you're using is very picky about how you represent dates and times. And so you really have to look at the database management system that you're using and figure out how it's representing dates and times. In MySQL, if we just use date, we have the year hyphen the month hyphen the day. You can see that here. So 4 slots for year hyphen 2 slots for month hyphen 2 slots for day. If you want to include the date and the time, you can do it like this, the space between the hours, the minutes, and the seconds. You can just do time as hours, minutes, and seconds, and you can see the constraints on it. So actually, interestingly enough, date time, or what is it, the timestamp only ranges up to 2038. So at that point, MySQL will hopefully be updated. The last set that we may or may not work with will be the large object data types. So if you have something like an image that needs to be stored, you can represent it as a blob. So I put a reference in here to the MySQL documentation about choosing a data type. So when you're putting a column in, here is what is recommended. For optimum storage, which is something that we do worry about, taking up space, especially if we have a lot of data, you should try to use the most precise type in all cases. For example, if an integer column is used for values in the range from 1 to 99,999, medium int unsigned is the best type. Of the types that represent all the required values, this type uses the least amount of storage. So you can look at the range of values that you think you'll have, and then decide what's going to be the least amount of space and choose your data type that way. So getting back to the business of actually creating a model on the Workbench, we have our location table, and we have decided to use int for location ID. We're not really sure how big it's going to get. For city, we can use varchar, and 45 is what they have as the default. I'm just going to leave it that way because I'm not really sure how big the city names are going to be. Let's keep adding attributes. So I'm going to double click, put in address, which again, think about what data type you need. We can leave it as varchar. Next attribute, we have state. Now state, I believe, is stored as 2 characters. So if we want, we can change this to varchar 2, which will imply that we only want a maximum of 2 characters when we have a state that's stored. So the other reason it's important to pick a proper data type is that it can help data entry. If somebody tries to put in a state with more than 2 characters, we will get an error and they won't be able to put it in the system. I just hit enter for the next one, and let's add zip code. Zip code, depending upon what we want to do with the zip code, we could either store it as a string or as a numeric type. If we want to use the comparison operators when working with a zip code, we'd probably want to use an integer type. But I don't think we're going to do that here, so let's just leave it as varchar. Finally, phone. Now the phone number has parentheses in it, so it is again something that we'll want to leave as a varchar, as a string type. Now we didn't add any of these constraints aside from the primary key and the not null constraint, but we'll address those momentarily. At this point, I think we have the location table defined in our model. So let's go ahead and pick out another table. Again, because of these foreign keys, we have to do position first. So I'm going to click this place a new table and click the canvas and then double click the table. I'm going to periodically save as well. So let's call this table position and start adding our attributes. So the first one being the position ID, and I'm going to leave it as an integer type, but I am going to specify that it is a primary key and that it is going to be not null. Now you see that it starts to generate an index as well. An index, to say it briefly, is just something that's generated by the database that allows for fast search. So it creates an index on certain columns in the table, and it will by default create an index on a primary key so that searches become much faster. Position ID. Next we have title. Title is going to be something we want to leave as a varchar. Education we can also leave as varchar. Now the salary we might not want to leave as text, because salary is something that we might want to ask a question like, who's making more than $50,000 a year? This is probably something that we want to use a numeric type for. So let's do min salary. Now also min and max salary in the position table are indicating the minimum and maximum salary for a particular position, not the actual salary of a particular employee. So let's pull up, instead of the varchar, I'm going to double click and then click the drop down and pull up the decimal type. Decimal is equivalent to one of the float point types that has fractional parts. We could use the int data type, but to be more accurate, a salary with currency could have fractional parts. So let's use decimal and specify the largest number of digits that we'll have. Now I don't think anyone is making more than 6 figures, so what we'll want to do is make it such that we have 2 places past the decimal and then 7 places in front of the decimal. So 7 plus 2, that's a total of 9 digits, and we want 2 digits past the decimal. And we'll do the same thing for the max salary. Declare it as a decimal with indicating 9 total digits and 2 digits past the decimal. I've accidentally created another column, so I'm just going to right click and say delete selected. Okay, we're now able to put our employee table into the model. So click here again, place a new table, double click, change the table name to employee, and then start putting in my attributes. So my first attribute is SSN, which stands for Social Security number. The question is, should we store it as an integer type, as a floating point type, or as a string? If we have a Social Security number that starts with leading zeros, then we should consider representing it as a string, because an integer by default will not have those zeros to the left. It won't have leading zeros. That's not a thing as an integer. So what we're going to want to do is actually represent this as a varchar instead. So I'm going to select varchar and we'll set it to 9 because that's going to be our limit for the Social Security numbers in there. Marked it as a primary key and not null. And then let's continue with the rest of the attributes. So we have last name, can leave it as a varchar. first name, also a varchar. Hire date, that's something that we should probably consider making a date, because sometimes we want to do operations on dates, maybe look for people who were hired before or after a certain date, and it will be treated differently if it's numeric. There's special operations you can perform on a date. So let's take the drop down and make it not date time, let's just use date, because we don't have the time included in the actual data. Salary, let's use the same data type that we did for min and max salary. So instead of a varchar, we'll make that a decimal and specify 9 total digits and 2 places past the decimal. The next one is gender. We can leave that as a varchar. Now I believe in the actual data it's represented as M or F. So we could set this to a varchar of 1. We could also change it to a char of 1 if we wanted to. Performance, probably should leave as a varchar. And then the last thing we're going to do is actually put in the foreign keys. So we'll give them the same names that they have in their reference tables. And the other thing is, this is very important, we have to make sure that they have the same data type, because if they don't have the same data type, we won't be able to set them as foreign keys. So position ID is an int in the position table, so we need to make sure it is an int here. Now, just by typing in position ID, that doesn't mean it is yet recognized as a foreign key. We're going to need to take another step in order to set that. We can also add location ID as well. And again, we need to make sure that we make that an int, because it's an int in the location table. Now, if we click back on the position ID, you'll see at the bottom, we have some different options, and one of those is foreign keys. So I'm going to click on the foreign keys tab, and here we can put in some foreign keys. So our first foreign key is our position ID. So we'll put in the name of the foreign key, position ID, and then we will choose its referenced table. So the reference table is position, and you can see that it actually generated the cardinality, the relationship line, for us. The other thing that we need to do is check the column for position ID and select that position ID. So let's do the same thing for the location ID. I'm going to double click and add location ID as a foreign key, and then choose gold star location as the reference table. You'll see that it also adds a connection there, and then choose location ID and location ID as the referenced column. So we've put our entity relationship diagram into the modeling tool in MySQL Workbench. What we're going to do now is use this tool to help us generate the SQL that will be our data definition language. So again, you'll have to be able to write it on your own, but I want to show you what it looks like coming off of the model first. Then we'll provide a simplified script for you to study. So what we want to do from here is save the diagram and return to the model. If we go back to the model, you can see the physical schema. Physical because it does have those data types included. Location, position, and employee tables. The first thing we're going to do is actually generate the schema. Now this is a very simple one-line script. So if we go back to the local instance tab and click inside the query editor, let's actually save this query. And I'm going to save it as create schema. When you're working with the data definition language, the way we create the schema so that it appears on the left-hand side is the following. Create schema, and then give it a name, gold star. Now I want you to look at the syntax here. We have create schema and it's in blue, and I've capitalized them. Some of them are case sensitive and some of them are not. It's not case sensitive, but it is the preferred syntax to use uppercase letters for some of the statements. So we have the command create schema. Those are referred to as reserved words, words that are defined by the data definition language. And then we've given it our name gold star, and I've made that lowercase and it's in black, so you can tell that it is not a reserved word. I've ended the statement with a semicolon. Every time we either have a line of data definition language or a line of SQL, we're going to end it with a semicolon. And this is cheesy, but I tell the undergraduate students to make sure that when you finish a line, you wink. So I don't know if that helps, but I'll add that note here. I said that you could generate the script from the model. So let me show you that really quick. We go back to the model. If I right-click on where the physical schema is, I can select Copy SQL to Clipboard. And if I return, you'll see that I can paste it underneath. And what it does is it actually has generated the corresponding language that I need. It's a little more complicated than the language that I used up here, but it will effectively do the same thing. This one has a few other keywords. So create schema if not exists. So it's going to first check to see if there's already a schema called gold star. It's put it in quotes and then indicated the default character set to be UTF-8, which is just the encoding. So I'm going to delete that because that's a little more complicated than the line that we're going to use. And then in order to run it, I'm going to hit the execute button, which is shaped like a lightning bolt. And what I'm going to do is then look at the output. You can see a green check that indicates that everything ran smoothly. I can see what was affected, how long it took, and the action that was taken. So here I've now successfully created the schema gold star. What I need to do then is right-click over here under schemas and go to refresh all. And now you can see that we've actually created the gold star schema. The database is now ready to go. If I click the drop down, I can see the tables and views, stored procedures and functions that are available. And as of right now, we have not actually put any tables in. The next thing we want to do is set the gold star schema to be our default schema. So I'm going to right click the gold star schema and say set as default. This will make it so that if we write a query, it will default to this schema. Now, just because I'd like to keep the different types of SQL that we're writing independent and separate based on what they're accomplishing, let's make another SQL tab. So I'm going to create a new SQL tab, and I'm going to save this one as create table. So create table, and from here we're going to generate the SQL to actually create the tables. So if I go back to the model, what I can do is actually right-click on the tables that we've created and choose Copy SQL to Clipboard. Now this is not totally foolproof. You have to make sure that the order in which you are creating the tables is such that you create any tables that have foreign keys last. So for example, let's start with location. I'm going to right click and say Copy SQL to Clipboard, return to the local instance where my script area is, and then paste. Now this is very convenient. I've generated the script, so create table if not exists. So it's going to check first to see if there is such a table. It is then going to reference the database schema gold star and say gold star dot location. So by putting the dot there, we're attaching location to the gold star schema. And then you can see all of the different columns that we created in the model and their data types and any other constraints that we do have. So for example, we have location ID, int not null, city varchar 45 null, and so on. We separate each of the different attributes with a comma, and then at the very end we have primary key location ID in parentheses. Also notice that everything after the table name is enclosed in parentheses. This line at the bottom we could eliminate. It's specifying the engine to use in order to create the table. So I'm going to save that and let's run it and see what happens. So I'm going to hit the execute button. You can see that I got the green check. And now if I refresh on the left side, you see that I actually have the location table here. Now in order to see what's in the table, and again, we're doing this from the graphical user interface point of view, I can right click on location and say select rows limit 1000. This will actually generate a query, which we'll touch on the next 2 days. And you can see the query as well as the results. We have not inserted any data into the database yet, so all we have is a list of the attributes. So let's keep going. Let's generate the rest of the tables. We only have 3. So I'm now going to go back to the model and right-click on position because there aren't any foreign keys there. And go to copy SQL to the clipboard, back to the local instance. And I can add it right below. Because it says create table if not exists, I can just append it here. Now you'll notice that I'm getting an error. So the question is, what's wrong? In this case, like I said, you have to end every single statement that you're making with a semicolon. So if we add that semicolon, you'll notice that the red line goes away. So syntax is very important. I can now save and run this as well. And you'll see that down at the bottom, I get a warning basically that the location table already exists, so it skipped it. But it did give me a position table in the actual database. So if I refresh, I can see both of those tables there, location and position. And you'll see it followed the same syntax as above. So we have create table gold star, which is the schema name, dot position, that's the table name, followed by everything in parentheses, and then all the attributes with the data type and any constraints that we have. So for example, position ID, data type int, with constraint not null. And then when I'm done with the attributes separated by commas, I add a final constraint that I want the primary key to be position ID. Let's return to the model one more time. Right-click on employee and choose copy SQL to clipboard. Go back to our scripting area. We do have a semicolon there, so let's add our final bit of code and end with a semicolon. Now from here you can see this got a lot more busy. We still have the same syntax, create table, schema name, table name, employee. We've then followed that up by the list of attributes with each attribute name followed by the data type and any constraints that they have. We have indicated primary key after the attributes, followed by what it has done is it's created an index for the foreign keys, so for the position ID and the location ID. And when we talk about tuning, we'll talk about indexes a little bit more. But for now, just realize that indexes are put in so that searches can be performed more quickly. We then have the foreign key constraints. So constraint position ID, foreign key, references, and it tells you which table and which attribute is referenced. So the foreign key name is position ID as it stands in the employee table. And that is a reference to the position table and the position ID as a primary key in that table. We have some extra notes here about what to do if it gets deleted or updated. And then we have the other foreign key, the location ID, which references the location ID in the location table. Now we're going to see a simplified version of this script, but I wanted to show you that you could right-click for this part to actually create the code. This is not going to be the case when we're doing data retrieval using the data manipulation language, but it is true here. All right, so let's save and run. And you can see that it's telling us we've already generated the location and the position table, but it has now created the employee table as well. And we didn't have any problems. So I'm going to right-click over here and say refresh. And you can now see that I have the 3 tables set up and ready to go to add data. The last thing that we're going to do is see how to rewrite that code but from scratch. So I do want you to be able to do that. So what we're going to do is start with a blank SQL file. I'm going to save mine and call it create gold star schema. And we already have a gold star schema, so instead of create schema gold star, we're going to start with create schema, let's just call it GS for now, because we're just using it as an example to show you the simplified SQL. I'm going to end the line with a semicolon, don't want to forget that. And let's add the other code snippet, so if not exists. So create schema if not exists GS, let's run that, and then refresh by right-clicking on this side. You'll see that GS now exists on the side. Now using the same sequence, but without referencing the model that we have on the other tab, we're going to create the tables for the schema. So a really nice resource that I want you to be aware of is the W3 Schools website. And on it, you can search for different SQL syntax, including the definition language pieces, as well as the manipulation language pieces. So here is an example of a create table statement, as well as the skeleton code. So you'll see it says create table, and that's in blue for the keywords, the reserved words, followed by the table name, followed by parentheses, and then all of the different fields with their data types. This is what we're going to follow. Remember that we have to create the tables in a specific order based on the foreign key placement. So let's start with the location table. So I'm going to say create table and indicate the schema, which is GS dot location. And then I'll include those surrounding parentheses with a semicolon. The other thing that we want to do is make sure that we include any object that we have in what's called the backtick. So not the single quote. The single quote, you'll see it turns to green. This is what we use when we have a string. What we want is the backtick. It's the key to the left of the number 1 on the keyboard. And it turns the text brown in this case. So we surround the schema object with a backtick, the schema object in the create table syntax with a backtick, as well as the table object location with the backtick. What this will do is if we use what otherwise would be a reserved word as an object, we can do that using the backtick. Otherwise, it will turn blue and we'll get an error. Now we want to add our attributes. So following the ERD, we have, again using the backtick, location ID, and we'll specify that we want it to be an int type and not null as our constraint. We're going to separate the attributes with columns. So the next one will be city, another backtick. City for us will be a varchar, and we'll use the standard 45. Next we have address, also a varchar. Then state, which we had as a varchar, we can use 2 as the limit. Next we have zip code, also a varchar, can use the standard 45. And finally the phone, which will also say is a varchar. The last thing that we'll do is include the primary key. So we'll declare primary key and in parentheses put the primary key, which is the location ID. You'll see that after I close the parentheses, the error goes away. And now if I run this, you'll see on the left side that I do have the location table. Now if we want to keep adding tables and run this again, we can add the if not exists statement so that we don't get an error when it tries to create the table twice. Next we'll do the position table. So create table if not exists. Use the GS schema dot position. I'm going to end right away the parentheses so I don't forget. And then let's list off the attributes. So position ID, which we have as an int and not null constraint. We have title, which is a varchar. Education, which is also a varchar. And then our salary, so min salary, which we said was going to be a decimal, And we have to specify the total number of digits as well as the digits past the decimal and the max salary, similar, decimal, 9 total, 2 past decimal. We also indicate that the primary key is the position ID. Finally, we can now create the employee table using similar syntax. So create table if not exists, gs dot employee, end the parentheses. And then we have the social security number, SSN, which is going to be a varchar of a max of 9. And we'll also set as not null. So notice I haven't added null after the others. Null is the default, so I can just leave it that way. And it will indicate the same thing as the more complicated code did. Last name, also a varchar, the standard 45. First name, varchar. Hire date, which will be a date. Salary, which will also be a decimal with 9 total, 2 past the decimal. Gender, which will be a varchar with limit of 1. Performance, also a varchar, standard 45. So then our last 2 attributes are the foreign keys, although we're not indicating that they are foreign keys just yet. So we have position ID, which is an int, should match the position ID data type above, and location ID, which is also an int. After this, we'll declare the primary key. Let me scroll down. I guess I have to space down. Add the primary key, in parentheses, the SSN, and then the foreign key. So foreign key, in parentheses, we have the name of the foreign key, so position ID, references the table name. So this is the position table, and then in parentheses, the name of the primary key, which is position ID, followed by the last foreign key, which is location ID, references, location, location ID. So let's check to see if that runs. And we do have successful run. We can check over here to see, if we refresh, that we have all 3 tables. Up to this point, I'd like you to be familiar with the create schema statement as well as the create table statement. In the next few lessons, we're going to go through different SQL queries.